Hello everyone, welcome back to my channel. Today we are diving into the world of data structures, especially focusing on binary search trees. I will walk through the creation of binary search tree, how to insert nodes into it, and finally how to invert the tree. Let's get started. First, let me create a tree node class to represent the single node in our tree. Class tree node. Sorry, name can be anything, it's up to you. I'm keeping it as a tree node, which will have a constructor taking the value to insert into node. Sorry, this dot value equal to value, this dot left equal to null, this dot right equal to null. So the node of a tree has three properties. One is the value to be inserted on the left node and right node. So whenever we create an instance of this tree node, it will initialize the value property with the given value and then make the left node and right node as null. That child nodes both will be initialized to null. Okay, this is a class to create or to represent the single node of a binary search tree. Now let's start creating a binary search tree class to represent or to manage our tree structure. Class search tree. Again, the name is up to you. I'm keeping it as a binary search tree. So which have one constructor to initialize the root node. So I'll be making it as this dot root equal to null. So this constructor initializes our binary search tree with the root set to null, meaning it's an empty tree at the start. Okay. Now next we should move on to the method or function to insert the values into the binary search tree, or to insert the nodes into the binary search tree. So for that, let me create a method called insert, which takes one argument, that is the value to be inserted into the node value. So the first thing we should do inside the insert method is we should create a tree node. So for that, const new node equal to new tree node. So for we have a constructor which is taking a value to initialize the value of our new node. So we should pass the value, this value, into this tree node class. So this creates a new node. Now before inserting the new node into the tree, first we should check whether the tree is empty or not. For that, new if this dot root equals to null, that means our tree is empty, we don't have any nodes at present. If that is the case, we simply assign the new node we created to the root node. That will be the root. So we simply do this dot root equal to new node. Okay, else if root is not null, that means the tree is not empty. If else, if the tree is not empty, what we'll be doing is I'll be creating a one more helper method, that is this dot insert node, for which I'll be passing the root as well as the new node. So what this helper method do is, this helper method will do a recursive search to find the correct position to for our new node based on its value. So now let me create a insert node helper method in order to recursively identify the correct position for our new node based on its value. So let me start creating it. Insert node which takes two values, that is node, that is a root node, and then new node. Okay. So inside this, what we have to do first is, first we should check whether the new node value is less than the root node value. For that, if new node dot value less than root node value, if it's less than, the new node should go into the left side of the tree, that is of the root node. Why? Because you know, right, in binary search tree always the left node should be less than root node and the right node should be greater than the root node. So for which, if the new node value is less than root node value, then the new node goes into the left side of the root node. For which, what we should do again, what we should check again is, here we should check whether the root node has any left child or not. If node dot left not equal to or equal to null, that means the root node has no left child. If there is no left child for the root node, we simply assign the new node to the left as a left child to the root node, that is node dot left equals to new node. Else means if there is a left child for our root node, then what we should do is we should again use the helper method to recursively find the correct position for our new node. So we simply call the insert node helper method again, for which I'll pass, if it's not null means we have a left node, so we should pass the left node of our root and then new node. That's it. So this takes care of inserting our let me zoom out so that you'll able to see the all code. Okay, now so if it's less than, it will go into this loop and then it goes till it finds the correct position for our given or for our new node. Let's say if it's not less than the root node value, then it should go into the right side, for which what we can do is sorry, else if, so it comes into the else loop and then it will goes into the right side. So we have to check is whether the root node has any right node or not. If the right child of root is null, then our new node will be the right node for the root. So what we can do is we can simply assign the node dot right equal to new node. Else if the root has a right child, that means right child is already present for the root node, then in that case what we should do is we should simply else again we should simply call the helper method in order to recursively search for the correct position based on the value of new node. Sorry. So for here we pass the right child of the root, that means node dot right comma new node. Okay, with this we will be done, or we are done with the logic to insert nodes into the binary search. So next is, our next thing is, as we discussed at the start of the video, first is insertion, the next is inverting the binary tree. So let me start creating method to invert the binary search tree. For that sorry, invert binary search tree using iteration. I'm using iteration. We can do the inversion of tree in two ways. One is recursive approach and the second one is iterative approach. Here I'm using iterative approach, using iteration. For iteration I'll be using queues. So this method takes one argument, that is the root node. So now before we go for the logic of inversion, we should first check whether the tree is empty or not. If the tree is empty, we should simply return null, that's it. Okay, if root equal to null, if that means tree is empty, then we should simply return null. Else, that means if tree is not empty, what we do is we simply first insert the root node into the queue. As I said earlier, I'll be using queue for iteration, so I'll be inserting the root into the queue, and then what I do is I will be iterating through all nodes until there are no child nodes, and then I'll process those nodes to invert or to swap. Inversion is nothing but swapping the right and left nodes, so that will create a mirror of binary search tree. So for that I'll be writing a logic, that is while q dot length greater than 0, that means until q is empty, we'll be loop through this code. That means we'll be loop through the all nodes of our binary search tree. So what we do is first we'll get, or we fetch the first element inserted into the queue. You know, right, it works in FIFO manner. So to get that, what we can do is sorry, current node equal to q dot, we have a one method, that is shift, which what shift method do is it will remove or fetch the first element of, or first value of q. If you see here, removes the first element from the array and returns it. So I will be using this. Now what we should perform the swapping. So for that I'll be using one temp variable, that is temp equal to, first I'll be assigning the left node of root to the temp, that is current node dot left. Now current node dot left equal to current node dot right, and then finally I'll be assigning the right node with the temp value, that is left node of the root. equal to temp. So here we are performing the, or we are added swapping logic. So what we are doing here is we are first assigning the left node of root node to the temp variable, and then to the left node of root we are assigning right node, and to the right again we are assigning temp, that is left node. So with this we are done with the swapping. Now what we should do is we should again check whether the left node of root is empty or not. If it's not empty, again we should process the childs of that left node again to swap it across. Okay, for that I am using one more logic, that is if current node dot left not equal to null, that means the root node has a left child or left node, then I'll be simply pushing the left node or to the queue. Sorry, not pop. Dot left. In the similar way, I'll be checking for right node as well. If right node is not empty, that means the root has a right child, then we should insert the right node into queue, so that we can further use it for processing further nodes. Okay, so if current node dot right not equal to null, that means there is a left child for root. What we do is we simply push to the queue. Okay, and then this loop continues until there are no child nodes. So that means until end of the tree. So once we are done with that looping mechanism and loop through of all nodes, we simply return root, that is inverted tree. Okay, so we are now done with the inversion. So okay, I'll be writing one more wrapper so that it will be easy to call instead of this big. Simply invert this dot this dot root. Okay, so let me format this. So we are now done with the two methods. So one is for insertion and one is for inversion. So now let's start implementation or example uses. So for that, what we should do is we should create a object for binary search tree. Const bst equal to new binary search tree. Okay, this creates an empty tree. Now insert values into binary search tree using insert method. So let me add 50. Let me copy this. Okay, 50, 30, 20, 40, then let me insert a couple more values. 70, 60, and then 80. So now we are done with the insertion of these values into binary search tree. So before inversion, let me see how the structure looks like, the tree structure looks like. So for which I'll be using one tool to show you the tree representation. So if you see here, this is I'm using to show you how the tree looks like now. Let's see, first value what we are inserting is 50. Let's insert 50. This is the root node. Next is 30. Since 30 is less than 50, it should come left side. Okay, it is inserted on left side. Now again 20. It now checks 20 less than 50, it comes to 30. 20 less than 30, so it will be the left child of 30. Now 40. When we are inserting 40, it first check with the root, that is 50. It's less than, so it comes to the left side. It checks here. 40 less than 30? No, right? It's greater than, so it comes to the right side of 30. Done. Next is 70. So 70 is less than 50. No, it's false. So it comes to the right side of 50. Next 60. Again 60 is greater than 50, so it comes to the right here. 60 is greater than 70. No, it's not true. So it comes to the left side of 70. Now insert the last value, that is 80. So 80 greater than 50, so it comes to the right side. 80 greater than 70, it comes to the right side. So 80 will be the right child of 70. So finally the tree looks like this. So 50, 30, 20, 40. So this is the tree final. So when we do inversion, how it should look like is this 70 comes here and 30 goes here, and then again 30 means the entire this entire node. So 30, 20, 40, this entire comes here, and then again these two will be swapped, like it will be like 30, 40, 20. This comes this side, that is 70, 80, 60. So let me open Painter to show you how the inverted binary tree looks like. So okay, let me drag this to this side. Okay, so now see, this is our tree. So when we invert this, how it looks like is this is 50. So this should go the right side, and the 70 comes, this entire this entire left node will go to the right, and the right node will come to the left. So that means here 70, again under 70, 60, 80. So these two nodes will swap. So then 80 comes on left side and 60 goes on right side. That means 80, 60, here it will be 30. Again these two should swap, that is 20 goes to right and then 40 comes left. So that means 40 and then 20. So this is how it looks when we do inversion. So after inversion it looks like this. So this is the before inversion, this is after inversion. Okay, now let me go to the code and then print the values to see whether the tree is getting inverted or not. Okay, before that let me add one more method to traverse the tree and then get the values. So here I am using in order traversal. This is one of the mechanisms which we can use to traverse across the tree for traversal. So here what happens is in order, first it will pick the left node and then root and then right. Okay. in order method. This is method I am using, for which I'll be passing two arguments. One is the node, that is root node, and then values, an array. Values is for to capture the values of, or to store the values of each node. Okay, values. So again here we should check whether root is null or not. If root is null, it simply means there is no tree. So if node is not null, then only we traverse the tree and then get the values. So since, as I said, the first left and then node main root and then right, here I am using recursive function to fetch all left nodes, values of all left nodes, and then main root node and then right node. Okay, this dot in order I am passing left node of root and then values. So next is here we will be pushing the values to the values array, node dot value, and then we will be traversing across the right child. This dot in order node dot right comma values. So this gives all values of node and store them into values array. Okay, now let me start printing the values of binary search tree which we passed or which we created. Okay, for that I am doing is values before inversion equal to initially empty array. Okay, this array we should pass to the in order function, in order method. Let me add one more statement, that is console dot log before inversion. Okay, so here we got one step, bst dot in order, for which I'll be passing bst dot root comma this array, empty array. So once we are done with execution of this method, we'll get values pushed into the array. Okay, now let me print the values for const value of values before inversion console dot log value. Okay, this is before inversion. In the similar way we'll print after inversion. So for that we should call bst dot invert method. Here we are inverting the tree. After this line, the tree will be inverted and we will be printing the value. So let me copy this and then what we are doing is this. Let me add it after inversion values. After inversion so yeah, this is after inversion. So now we are done with it. Let's see the execution. So to run the JavaScript using node instead of browser, the command is node and then the path. Sorry. src, sorry, src, and then this is created under demo. Yeah, demo, sorry, demo. Name, class name is binary search tree inversion using, okay, sorry, something went wrong. What is wrong here? What is wrong here? Node, okay, cannot read properties of undefined reading value. Why? What we did is we created this constructor and then what went wrong here? Let me check. Everything is correct only, right? This dot root, okay, this dot root, correct root, insert node, this dot root, it comes here, node, new node. What's wrong here? Cannot read properties of undefined reading value. Why it is undefined? We created tree node as well, right? Okay, class tree node, correct. Null RIGHT, oh sorry, GHT, okay. Okay, let me see wherever we used right. Correct. Right again here, wrong. Left, right, okay. RIGHT, okay. Now let me see again. Control S and then yep, that is the issue. So I mistakenly typed right node, so I missed, I think T or G, yeah, I don't know, whatever, I mistakenly typed it. So okay, now if you see here, see this is before inversion. So whenever we see a binary search tree and then we traverse in order, all the values will be in ascending order before inversion. If you see here 20, 30, 40, 50, it's ascending order. But after inversion, the value should be descending order. If you see that is why, because as I said, sorry, this is our inversion inverted tree, right? So if we traverse in order, that is left, root and then right. So it starts from here, that is, I mean, when it comes to in order, first starts from the left child at the end of the tree, that is 80, and then goes to 70, right? Again from here it goes to root 50. Here again you should start from left, right, that is 40, 30, 20. That means descending order. So if you see here, all values are in descending order, which means the inversion happened correctly. Okay, thanks for watching. This is for today's video. Please do like, comment and share. Please let me know in the comments if you are interested in any other topic. I will take a look and then try to come up with a new video of respective topic. Thanks again. Please do subscribe and do like. Thank you.